Hi and welcome back. Over the past few videos, we've been talking about the atomic number, and if you remember, we're looking at our periodic table again, and our atomic number is going to be this number, this bold number. So for beryllium, our atomic number is 4, and that means that we are going to have 4 protons in the nucleus of some atom in order for it to be beryllium. And so anyway, we were talking about how the atomic number, essentially what determines what element it is that we have an atom of, is the number of protons in the nucleus. And one of the things that we had kind of talked about was how the atomic mass, so the atomic mass of a given atom, was equal to the number of protons plus the number of neutrons. And so when we say, I think I gave you the example of a helium atom in a past video where I said, okay, so a helium atom has got normally it has it has 2 protons and it also has 2 neutrons. So we would have an atomic mass of 4 AMU. So we went over this in the last video, and now I guess I'm going to show you on the periodic table, if you see these really tiny numbers right below the atomic symbols, and actually I'm going to scroll up, I got a bigger version of this same periodic table. If you can see these little numbers, so we're going to look at hydrogen a lot in this video. If you can see this little number down here, this is going to be, let me choose a darker color. This is our atomic mass. And so something might strike you when you first see this, and namely, I was telling you that the atomic mass was going to be equal to the number of protons plus the number of neutrons. And so something might strike you when you first see this, because it's not a nice whole round number, right? We've got 1.0079. So it looks like, what, did one of these protons split in half, or, are we only counting, a certain number of protons, or, do we have 1 proton and 0.0079, or I guess that would be 79 ten-thousandths of a neutron? And what the answer is that this is because, and we'll go into this more in the future, but this is because hydrogen has got different isotopes. And essentially what an isotope is, if you remember, we said that the atomic number, so the atomic number, hydrogen's atomic number is 1. That means in order for us to have an atom of hydrogen, it has to have 1 proton. So if we have an atom that has 1 proton in its nucleus, then by definition, we have got hydrogen. However, it doesn't necessarily matter that much how many neutrons we have. So we could have, normally a hydrogen atom, and you can see that, well, anyway, I'm getting ahead of myself, but normally a hydrogen atom, the most common isotope of hydrogen, and is going to have 0 neutrons. Another isotope of hydrogen could have 1 proton and 1 neutron. A third isotope of hydrogen could have 1 proton and 2 neutrons. So essentially what isotopes are is you could almost view them as different versions of the same neutral atom. And keep in mind that all of these, because we've got 1 proton, all of these also have got one electron too, because they're neutral atoms and the charges are balancing out. So we could essentially say that an isotope is going to be a different version of an atom. And how is it a different version? Well, it's just a different number of neutrons. So if we see an atom that has got one proton, by definition, if we have one proton, we're always going to be looking at hydrogen. But if we have two different atoms that we're comparing and they each have one proton, one has 0 neutrons, and the other one has got 1 neutron, has got 1 proton, 1 neutron, and 1 electron, then these are different isotopes of hydrogen. And there are a couple of ways that we would write these down, and I will get to, probably in the next video, I will get to why we have a decimal here in this number for our atomic mass of hydrogen on the periodic table. But for right now, let me just show you the way that we would write down these different isotopes of hydrogen. So normally, the way that we would write it, and this is, I guess, the way it's normally given, is you would have some letter, let's call it B, up here, and this is going to be our mass. So it's going to be the mass, or we could say the mass number, or it's essentially going to be the atomic mass. It's going, this number B, actually, you know what, I'm going to give myself, sorry, I want to make this look a bit nicer so it's a bit less confusing. Okay, here we go. So our mass number is going to be B. So this is essentially going to be the atomic mass. And then we are going to have our symbol, and the symbol is usually denoted as Z. So this is going to be our symbol for the element. So in the case of hydrogen, that symbol, and I shouldn't have written over it so much, but that symbol is going to be H for hydrogen. And then the last thing we've got is some number A down here, which is going to be our atomic number. So let's talk about, we've got 3 different isotopes of hydrogen here that I wrote down. One is, they've all got 1 proton, one has got 0 neutrons, one has 1 neutron, and one has 2 neutrons. So using this convention, how would we write those isotopes down? Well, each of them has an atomic number of, let's start writing each of these down. So I'll write down the first one. Each of them, the symbol is going to be H. So we've got an H there, an H there, and I'll say, what's a good color here? An H here. And then the atomic number for each of these, each of these all have 1 proton, right? That's what defines that we have hydrogen. So the atomic number for each of these is going to be 1. So write down 1 there, write down 1 there, and then write down 1 here. But now for the atomic mass. What's the atomic mass going to be? Well, it's going to be the number of protons plus the number of neutrons, right? So for this first one, we've got 1 proton and no neutrons. So our atomic mass is just going to be 1. So essentially, our nucleus of this isotope is just going to be a proton. And we'll find out in a future video that this is going to be the most common isotope of hydrogen. By far, it's going to be the most plentiful in nature. And then the next one, so we've got 1 proton and 1 neutron. So what's our atomic mass going to be? Well, it's going to be 2, right? It's the number of protons plus the number of neutrons. And then finally, we've got our third isotope of hydrogen, which has 1 proton and 2 neutrons. And so we just add those together, and our atomic mass of this isotope is going to be 3. So there are 3 examples of some different isotopes of hydrogen. There's another way that we could also write this down, or sometimes it's written down, because essentially, and you can kind of see it this way, if we have the symbol of an element, we don't really need the atomic number, do we? Because we don't, or if we know what element or the name of the element that we're dealing with, to have the atomic number is somewhat redundant because, you know, in order to have that atomic number, that's what essentially defines the element. One proton defines hydrogen. So sometimes what you will see these isotopes written as is we would write out the whole name. So hydrogen, and then hyphen with the atomic mass. So this could be hydrogen 1. So you might see that notation somewhere. And again, you know, we've omitted, this is going to be, so this 1 right here, this is our mass number. For the next one, it would be hydrogen dash 2, because our atomic mass for this isotope of hydrogen, this isotope is going to be 2, right? And then the third one, you can probably see where this is going to be hydrogen dash 3, because that's going to be our atomic mass. And you can see that we left off our atomic number because you know, it was almost kind of redundant, right? We didn't necessarily, you know, in order to have an atom that's considered hydrogen, we need to, by definition, our atomic number is going to be 1. By definition, it is going to have 1 proton. So anyway, hopefully that gives you an introduction into isotopes. In the next video, I'll hopefully talk more about why this number on the periodic table for hydrogen, why that isn't a round whole number, and hopefully give you give you the reason why. And so anyway, I'll see you in the next video.